Everyone. Today, let's go over another early grind 75 question in the easy category. This is a stack question. It's called Implement Queue Using Stacks. And this is part of a series where I'm reviewing questions I solved a while back. This was solved over half a year ago, so it's good to review. So this one asks you to implement a first in, first out queue using only 2 stacks. And the queue should also be able to pop and peek and push and empty. So push essentially just means pushing to the rear of the list. Popping means popping the rear of the list. Peeking means peeking from the front of the list, which is a 0th index. And then emptying means clearing the list, right? Pretty simple, pretty straightforward. Note that you may only use standard operations of the stack. So a stack may not be supported. You may simulate a stack using a deck. Python has a deck, but we don't really need that here. If you look at the examples, the constraints are really small, so we can basically just follow the instructions, right? So let's define a stack. And to push to the stack, let's append x. So this is going to, let's say, x is 2. This now becomes 2. X is 1. This now becomes 2, 1. All right, so the rear of the stack is what append does. And then popping from the stack is the same thing from the rear, except we also want to return it. So return self.stack.pop, right? Because this is not only popping, but also is a variable itself. So let's say you have your list. So return self.stack.pop will give you 1, and the list will now look like this. So we're going to return this, and the list will now look like this. Peeking is simple. So let's say we have our list right now. Now we just want to return self.stack0, which is the only element. Well, if the list was bigger, we'd get this one. That's peeking. So the 0th index. And then empty, we just return if the stack has elements in it. Self.stack. This is the same as if length of self.stack is bigger than 0. Same thing, self.stack. That's how Python works in this case. Let's see, maybe not in this case. So it looks like we pop and we empty. Turns the element at the queue and returns it. Okay, so it looks like we actually want to return the front of the queue. So leftmost. So in this case, stack 0. Let's call it A. So instead we want to return this one. So we want to return this in our list. We want it to look like this. So the opposite of what we did before. And then delete self.stack A and then return A. Okay. So, or maybe we can just self.stack.remove A. Empty is not correct. Print self.stack. Let's see. There's still elements in there. That's weird. Okay, so let's see what's going on here. Pop from the front. Or maybe we can just use a deck instead. And self.d.append. Return self.d.pop left. Same thing. Return self.d0. Or perhaps the front of the queue here means -1. I don't know. Return self.d. Or length of self.d is bigger than 0, meaning it has elements in it. Okay. D0. Oh, that's strange. I don't know. Print self.d. Print self.d. Okay, so why is this supposed to be false? I'm confused. You want to return the element at the front of the queue. Oh, maybe we also want to delete it. So pop usually just means from the rear. So maybe this way. Okay. left. Q is 1, yep. And then Q is this, so we want to push, yep. Want to return 1 from the peak operation, yep. Turn 1, the Q is 2. So pop removes the element from the front of the Q and returns it. Returns the element at the front of the Q. Self.d.pop. We're just going to have to play around with this a little because the language is pretty unclear here. What we're being asked to do Okay. If the queue is empty, okay. False. So there we go. Other way around. Yep. So it looks like here this could be better worded because we're not even popping, we're just returning it. And then here we're actually removing and returning it. Okay. Cool, cool, cool. So I misread a little bit here. I thought this is also means popping, but it does not. And then this is opposite. If it's empty, return true. If it's not empty, return false, not the other way around. So it's good to read carefully next time. And so that's it for this video. Thank you for watching and take care.